told you we're going to start off with cartilage. Again, this is part of the skeletal system. We find it anywhere where we need a little bit more flexibility because it is a little more flexible than bone. It actually has a higher water content, which makes it more resilient and a little more springy than bone. Now remember, one big difference though between cartilage and bone is that cartilage does not have a blood supply. If you damage your cartilage, it takes a lot longer to heal than if you break a bone. And that has a lot to do with the fact that it has no blood vessels in it. Now it also has no nerves, right? Has anybody damaged their cartilage before? Like in the knee, meniscus, torn, nothing? None of my ball players have had any like cartilage injuries? Wow, that's amazing. So people who've had cartilage injuries, a lot of times they'll say, you know, but I tore the meniscus in my knee and it hurt a lot. How is that possible if there's no nerves? So cartilage is really tough tissue. It's kind of hard. The best way that I can help you sort of imagine what it's like is think of a chicken wing. You know, if you eat chicken wings, you eat all the meat off of it. You know that really slippery stuff at the end of the bone that's still like so tough? That's cartilage. So it's really tough. It's just real slick. If that tears, what happens is the shape of it changes and it bubbles up. And so now you can imagine like your knee joint. If your cartilage in your knee bubbles up, now every time you bend your knee, you're rubbing your bone on that big projection that's sticking there and it hurts. So that's actually hurting because your bone is rubbing on it. And so this is why you might feel it if you damage your cartilage. It's going to hurt. Now your cartilage is surrounded by something called the perichondrium. Let's look at this word. Okay. Peri means around. And chondro means cartilage, right? So perichondrium literally means it goes around the cartilage. So I think of the perichondrium very similar to the way I think of the periosteum. It is sort of like the Spanx for the cartilage. Guys, if you don't know what Spanx are the way that we trick you into thinking that we're thinner than we are. Spanx like hold it all in, right? They suck it in. That's kind of what the perichondrium is doing. It wraps around the cartilage and it sucks it all in and it holds it in. And it truly keeps it from expanding outward. Again, think of Spanx, right? Keeps stuff from spooging out, expanding outward. Now, the perichondrium also is going to contain blood vessels. That's really important. Does cartilage have a blood supply? No. So how's it going to get nutrients? Diffusion. Anytime you have a tissue that does not have a blood supply, it's going to get its nutrients through diffusion from a nearby tissue. So perichondrium does have a good blood supply. It has to, because this is how your cartilage is getting nutrients, through diffusion. Now we've talked about the three kinds of cartilage. I'll just remind you what they are. There's hyaline, elastic, and fibrocartilage. All of these contain a type of cell called a chondrocyte. Remember, chondro means cartilage, cyte means cell. And remember, anytime we're looking at a tough tissue like cartilage or bone, if it's tough, the cell is found in a little hole called a lacuna. Okay, so all three types of cartilage have chondrocytes in lacuna. So let's walk through our three kinds of cartilage. The first one is hyaline cartilage. Hyaline cartilage provides a lot of support, a little bit of flexibility, a lot of resiliency. This is actually the most abundant skeletal cartilage that we have in our body. So where do we find this? We find it at the end of all of the long bones in your body. And we call this articular cartilage. So the term articulate is a joint. So if you look at this skeleton, we would say that this is an articulated skeleton. It is put together, it has all of the joints in place, okay? If I grab one of these boxes that you're gonna look at in lab this week, and I can pull out one of these bones, right? This box contains a disarticulated skeleton, right? There's no joint. Okay, so articulate is a joint. So we call it articular cartilage because it wraps around the ends of every long bone in the body. So I want you to look at this skeleton. Most of the bones in your body are long bones. Almost all the bones in your limbs are long bones, and wrapped around the ends is articular cartilage. This is just going to help to reduce the wear on the bones as you move the joint. Okay. We also have a type of cartilage called costal cartilage. This is one I've already mentioned. This one connects the ribs to the sternum. This is made of hyaline cartilage. Hyaline cartilage also makes up your larynx, which is your voice box, and it reinforces your airway. So if you look at the trachea, which is your windpipe, your airway, it is this light blue structure. Okay, so you can see it here, and then you can see it branches into bronchi. This actually contains rings of hyaline cartilage in it. And the rings actually hold your airway open. They provide what we call a patent airway, an open airway. And so those are called respiratory cartilages. These are important that your airways stay open. You do not want your airway to collapse, as opposed to like the tube that sits behind your trachea is called the esophagus. It's a muscular tube, it carries food. It is not held open all the time. In fact, when there's no food moving through the esophagus, it's flat. So you can see that when you look at the rat. You can tell the difference when you look at the trachea versus the esophagus behind it. The trachea is nice and open because of those cartilage rings. And then we also have nasal cartilage. This supports the nose and gives it a structure and a framework. So you can tell hyaline cartilage is definitely the most abundant just based on where we find it, which is pretty much all over the body. Now, another kind of cartilage we have on our skeleton is elastic cartilage, similar to hyaline, but has way more elastic fibers. So it's much more stretchy, it's much more flexible. So we're going to find this in the pinna. And the pinna is basically the external ear. So the pinna, you can tell if you can move your ear around, it's nice and flexible, it springs back into shape, right? That's elastic cartilage. The other one is the epiglottis. The epiglottis is a little flap made of elastic cartilage, and we find it at the top of the trachea. So it basically is a little flap that will cover over your trachea. Sometimes it's referred to as the guardian of the airway. Okay? And the reason for this is because you have two tubes that go to the back of your throat, the pharynx, the trachea, and then right behind it is the esophagus. What moves down the trachea again? Air. And what moves down the esophagus? Food. Okay. Now remember, both of those are going into your pharynx, the back of your throat. From there, we have to funnel them into the right tube, right? Air goes down the trachea, food down the esophagus. So at the top of the trachea, you have an epiglottis, the guardian of your airway. This ensures that food does not accidentally go down the trachea. That's called aspirating food, and you can die from that, right? This is why you cannot breathe in and swallow at the same time. Okay, that epiglottis will close over. How many of you just tried to swallow your spit and breathe at the same time? I feel like everybody always does that when I say it. You can't do it. The last type of cartilage is called fibrocartilage. Now, fibrocartilage is the one that has the most tensile strength. So you're gonna find this in areas where you have a tremendous amount of pressure. The reason it has the most tensile strength is because it has a lot of collagen fibers. Remember, these are the ones that are stronger than steel. Okay, so a piece of collagen with the same diameter as a piece of steel is 1,000 times stronger than that piece of steel. So they're very, very strong fibers. So we find these in places like the meniscus of the knee, where you have a lot of pressure, running and jumping. We find these in the intervertebral discs. The intervertebral discs are these pads of fibrocartilage between your vertebrae. And you can imagine the amount of pressure on your back all the time, standing up against gravity, right? You can imagine the pressure on the meniscus of the knee. You can imagine the pressure here in this pubic symphysis. Okay? This is like a little bowl that's holding everything, all of your abdominal pelvic organs and everything above your hips is being held right here. And so you have this little pad of fibrocartilage. So anywhere where you have a lot of pressure is where you're gonna find this. So here's an image from your book that shows you these 3 types of cartilage and where we find them in the skeleton. In blue, that's all hyaline cartilage. So you can see that's going to be the majority of the cartilage that you're going to see. In green is our elastic cartilage. So you can see the pinna, and then you can see the epiglottis. And then in red is fibrocartilage. This is the one that can withstand a lot of pressure. So you can see the meniscus, the pubic symphysis, and the intervertebral disc. The last thing I want to mention about cartilage is how it grows. So cartilage is going to have to grow with your skeleton. Cartilage is a little more flexible though than bone. It does have a flexible matrix. So cartilage can grow 2 different ways. It can grow through what's called appositional growth. This is growth from the outside. So this means that the cells that are in that perichondrium, the spanx of the cartilage, those cells are making more cartilage. They're secreting the matrix onto the existing cartilage, and basically the cartilage is getting fatter, it's getting wider, okay? Growth from the outside. Interstitial growth, inter means between, so this is growth from the inside. So with interstitial growth, chondrocytes and lacuna are dividing and making new matrix deep inside the cartilage, not from the outside, but deep inside. Okay, so the cartilage is being built from within. So you may want to start this slide to make sure that you remember that we're talking here about the growth of cartilage, not the growth of bone. Okay. Now cartilage can become calcified. When you add calcium to a tissue, what happens to that tissue? It gets harder, right? The more calcium you add to it, the harder it gets. One thing I want to make very clear is that when you add calcium to cartilage, you are not turning it into bone, okay? Bone and cartilage are 2 totally different tissues. When your body adds calcium to cartilage, all you're doing is making your cartilage less flexible. You're making it harder. Now, this is a normal process as your bones are growing. The cartilage near them and around them at the ends will calcify. That's a normal process. But again, we're not turning that cartilage into bone. That doesn't happen. Bone and cartilage are 2 different tissues. The other thing that can cause cartilage to calcify is just age. As you get older, you'll start to put more calcium into your cartilage. Makes your cartilage less flexible, which is why as you get older, you get a little less flexible.